Hello everybody, I hope you are doing well and welcome to the platform of CodeChef. So today we're going to be solving the problem best maximum product. The difficulty level for this problem is easy and prerequisites require a basic knowledge of greedy algorithms. So there's your dedicated Ansh and I hope you like my video. Let's proceed with the problem statement. Okay, let's try to understand the problem statement. So basically in this particular problem, I'm given an array of n integers and a number k. And I have to find the maximum k product of an array. So basically the maximum k product of an array is the maximum product of any k length subsequence of an array. For example, the maximum 2 product of minus 5, 3, 4, comma minus 6 is 30 because minus 5 into minus 6 is equal to 30 and it is impossible to achieve a larger subsequence product than this particular product. So what is the maximum k product that you can achieve? And since this answer can be very large, we have to output it modulo 10 power 9 plus 7. Okay, so in this question, as you know, we are told that we are given an array of n integers and I have to find my subsequence of k integers such that the maximum or the product of that particular sequence is maximum. Okay, so let us see the test cases given in the question and see how the product is coming maximum and what should we do. So basically, as you can see here, my n is 4 and my k is 2. So we have one option of taking 6 into 5, which is 30, and another option of taking minus 3 into minus 4, which is 12. So apart from that, any combination will result in a negative number, and that is obviously less than a positive number, so I'll discard it. So out of these possibilities, as you know, 30 is the maximum sum, and hence I output my answer as 30. So in my second test case, as you can see, it is optimal for me to take minus 5 and minus 6 as a two-length subsequence because my minus 5 into minus 6 is 30 and there can be no greater sum achieved apart from this. Now in my third test case, it is obvious since all are positive numbers, we can take the maximum, which is my 1 10 power 5 and again one other 10 power 5. So basically that is nothing but 10 power 10, but we have to take modulo 10 power 9 plus 7 and hence the resultant number is nothing but 99937. And finally in our configuration of 2 comma 1, since we are forced to take only one and all the array is negative, so we can just take the smallest negative number possible. So minus 1 and minus 1 modulo 10 power 9 plus 7 is nothing but 10 power 9 plus 6. That's why this is the answer and these are the test cases. Now let's see how we can approach this following problem. Okay, let's try to understand the approach for this particular problem. So roughly our approach can be categorized into three types. So firstly I'll take my array A and sort it. So now I have all the values of my array in the increasing order. Now I can apply the condition if my A of minus 1 or the last element of array is less than 0 and my k is an odd number. So basically I'm talking for such case when my firstly I sorted my array. So if my last element is less than 0, that means the elements before it will be definitely less than 0 because the array is in sorted fashion. That means the entire array is negative and my k is also an odd number. The configuration will be like this. Say I have an array such as minus 1, minus 2, minus 3, minus 4, minus 5 and my k is equals to 3. So in that particular case, I have to choose the greatest negative numbers and then take their product to get our answer. So this is the idea for this particular case. So once we handle this case, we can simply put another case as if my a of minus 1 is equal to 0 or my last element of array is 0 and my k is odd. That means, so firstly, why k is equals to odd is a problem because if k was an even number, if k was simply an even number, in this particular case, my negative would be get cancelled out. So simply I would take the sum with absolute values with its maximum and simply I can just take their products to get their answer if my k was even such as 4. But since k was odd, that was the problem, so we took the greatest negative numbers and got our answer. If k was even, we could just take in the smallest negative numbers and add them or multiplied them in order to cancel their negative signs and get the desired answer. Okay, so now for another case, if my last element of A is 0 and my k is an odd number. So what happens in that case is, firstly, since my array is in sorted order, and my last element of array is 0, that means all the elements before the array are either 0 or negative. In any of the cases, if my k is an odd number and my all the elements are negative, I know that the product that I'm gonna get will be a negative number. But if I have any one element as 0, I can make the entire product of array as 0. So 0 is still a better sum than any negative number. Hence, the answer for this particular case is simply 0. 0 should be taken as a product of sum. If my in a sorted array, if my last element is 0 and my k is an odd number. So apart from that, so I'll write it an else if condition. Okay. So apart from that, in any other case, we can form a greedy strategy. And how will that greedy strategy work? It is simple. Since we sorted the array firstly, so my array was sorted, so a dot sort, and then what happens is we can just simply take, so consider any particular configuration of an array. Now I have concluded that my a is not all negative, my k is not odd, like we have excluded all these particular test cases. So what we can do is, my sorted array will mostly contain some negative numbers in the back followed by some positive numbers in the front because it is in sorted fashion. Even if that's not the case, we can handle each and every case via this. So what we'll do is we'll try to pair first last two numbers and pair first two numbers in the array. The entire goal is we can pair two negative numbers and we can pair two positive numbers in the sorted array. So basically, whichever product is giving us maximum, since our negative negative will cancel out, it will give us a big number, which is because obviously the last two elements are my greatest or my smallest negative numbers. So basically, it will be something like minus 4, minus 5, minus 4, minus 3, and this will be like 1, 2, 3, 4, something like this. So basically, my smallest negative numbers will turn out to be my greatest products because the negative sign will cancel out. So in this case, minus 5 into minus 4 will turn out to be 20, and in this case, 3 into 4 will turn out to be 12. So what we'll do is, at every step, we'll do this for k by 2, because in every iteration, we are taking two elements, we are checking the product, and whichever product is greater, we'll include that particular product in our answer. So we'll multiply that particular product in our answer, and then if suppose this particular product is included, we'll shiftly point the two pointers to the next elements. And similarly, if that particular sum was greater, we could just simply point our pointers to the next element and we'll move on until we do k by 2 iterations. Because in every iteration, we are considering two elements. That's why we're taking k by 2 iterations. And at every iteration, whichever sum turns out to be the maximum, we'll just multiply it in the answer and keep taking mod in every step because the question has told to take modulo 10 power 9 plus 7. Yeah, that is the approach for solving this particular problem. Now let's see how we can implement or code this particular approach. Okay, let's try to understand the code for this problem. So firstly, we take t as the input. For each test case, we take the input according to the input format. Then, as discussed in the approach section, firstly we sort our array, right? After sorting an array, I initialize my product as 1 because multiplication with 1 itself won't affect any number. Then, as I discussed, there's one of my cases that if my last number was 0 and my k was odd, and we discussed in the approach section that we have to print 0 in this particular case, because if in my sorted array my last element is 0, then that means all elements before it will definitely be less than 0, and my k is odd, so the result, if I take any other number, will turn out to be negative, so it is better to take 0, and that's why I printed 0. Otherwise, if my array minus 1 was less than 0 and my k was odd, that means my all elements in the array are negative and my k is also odd. So we'll simply take the subproduct of greatest negative numbers and just get a required answer. So we just took the sum of greatest negative numbers and we got or printed a product, right? Then for my else case, I simply took my I as 0 and j as n minus 1 as we discussed the two-pointer solution. Now, if my k was mod 2, that means if my k was odd, I just simply selected my last element and I decremented this particular element by 1. So I just decremented by my jth element and also decremented my k because I used one of the elements in my product, right? Now, we simply do the thing that we did for the approach section, like for I range k by 2, Since my k will be an even number because if k was odd, we reduced by considering an element, we simply take the following thing. So we just simply check the product for the particular array. So if my array of I into array of I plus 1, which was considering the first two or the negative numbers, and my array of j into array of j minus 1 is considering my two positive numbers. So which out of them two, whichever is maximum, and consider them in including my product. And yeah, so if my this particular sum or sorry, if my this particular product is maximum, I'll include that this particular product into the final product, and otherwise I'll include my other product into the final product. So again the same idea, pairing two negatives with pairing two positives, whichever turns out to be the maximum product, include them into your sum and increment your pointer by that much. So yeah, we just shift the pointer by that much, and finally after doing this iteration for k by 2, we get our final answer, which is the product, and we print it for each particular test case. So now let us run our code into the sample cases to see whether everything is working correctly or not. So as you can see, our code has successfully passed the sample test cases. Now let us submit our code into the actual test cases to see whether everything is working perfectly or not. So as you can see, we got the correct answer for the following problem, and yes, this becomes a valid approach. Right? Now let me discuss one thing where other people could go wrong in this particular problem. So here I have a sample solution that received a verdict of time limit exceeded. What this particular person did wrong was while taking the product, he didn't take modulo. Like for the entire iteration, he kept on taking the product. And as you know, since a product can be quite big, so this might be one of the cases for TLE. Like as you generate your big numbers, your multiplication becomes slower and slower because it has to calculate that precisely. So if your negative number or if your product increases beyond a certain level, your operations become quite slow, and that might be one of the reasons why you get time limit exceeded error. So always whenever you're taking product and whenever it is given, take modulo 10 for 9 plus 7, take modulo in each and every iteration so that you don't get such kind of errors and your answer remains within the time bounds. So this is the learning you get from solving this particular problem. I hope you like my video. Please like, share and subscribe to our channel. Thank you.